All right, problem 101. What is the area of a triangle that has these vertices? All right, so let me plot these points first. -1, 0. That's A. Then I have B, which is 4, 5. There's B. And C, which is 7, 0. There's C. Okay, so the base is horizontal. That's really nice. All right, and the base is how many units long? 5, 6, 7, 8. 8 units long. And what's the height? The height starts from the top going down. 1, 2, 3, 4, 5. All right, so area of a triangle is half the base times the height. Base is 8. H is 5. So I have 4 times 5, which is 20. So the area is 20 square units. Done. All right, what is the area of this triangle with the given vertices? All right, let's plot the points. -2, 0. Oop. -2, 0. Then I have B, which is over 5 up 9. That actually goes off my grid here. Okay, it's not too far off though. Then I go to the right 8. 0. Okay, so here's my triangle. And the base is horizontal, which makes this easy to do. So I have the base, which is 3, 4, 5, 6, 7, 8, 9, 10. 10 units long. And the height, which is 2, 3, 4, 5, 6, 7, 8, 9. 9 units long. All right, area of a triangle is half the base times the height. So the base is 10. The height is 9. So I have half of 90. Could do it that way, which is 45. So the area of the triangle is 45 square units. Done. All right, in the diagram, angle 6 and angle 13 are supplementary. 6 and 13, they're supplementary. All right, if they're supplementary, that tells you that these consecutive interior angles add up to 180. And if that's the case, that means these lines here are parallel. Okay, which two lines, if any, must be parallel? Okay, well, that answers the question. A is parallel to B, or A and B are parallel. Alrighty, that's all there is to it. And just to further clarify, these are your parallel lines, and this would be your transversal. Okay. In the diagram, angle 12 and 14 are supplementary. 12 and 14 are supplementary. All right, those are consecutive interior angles. They add up to 180. So then these two lines here, they must be parallel. Okay, this is your transversal here. So which two lines must be parallel? That would be L is parallel to M, or L and M. Done. Find the value of B in the diagram. All right, we have 3 angles for the triangle, and they all add up to 180. All right, simple algebra problem here. So I have 41 for B. Done. Find the value of x in the diagram. Okay, the three angles of a triangle add up to 180. X is equal to 150. X is equal to 75. All right, in the example, what properties of algebra are being used? Okay, right here we're applying the division property. All right, and the next step would be the distributive property. And there's two ways to look at this. Okay, you're essentially dividing both by 2. All right, so that's like distributing. Or you could think of it this way. Let me write it out like this. Instead of thinking of this as dividing 2x minus 6y by 2, think of it as multiplying it by a half. Okay, so then we're distributing it, and we end up with 2x over 2 minus 6y over 2. And those match, right? So you're distributing. Done. All right, in the example, what properties of algebra are being used? Let's see what we have here. Okay, we're subtracting 3x from both sides. That would be the subtraction property. And then what happens next? Okay, now whenever you throw parentheses into an equation and you're grouping different parts, that's known as the associative property. Alright, so it's a very simple idea. Just, it doesn't matter how you group parts when you're adding or subtracting, it still turns out to be the same thing. Alright, so whenever you throw in parentheses, it doesn't change much when you're adding or subtracting. Done. Write the equation of the line that contains this point and is perpendicular to the line. Okay, so perpendicular means that I take this slope here, I flip it, and I make it negative. Alright, that's the slope I have to work with. So standard equation of a line is y equals mx plus b, slope-intercept form. Now make sure you don't use this b. Okay, do not use that. That's why we have the point here. This helps us figure out the b that we need. So I have 1 is equal to m, which is what I just figured out, negative 2/5 times x, which is negative 5, plus b. Alright, the 5's cancel out. Watch out for the negatives here. It's going to become positive. So I have 1 is equal to 2 plus b. Subtract 2 now, and b is equal to negative 1. Okay, so to complete my equation, y is equal to negative 2/5 x minus 1. Done. All right, write the equation of the line that contains 4, negative 3 and is perpendicular to the line y equals negative 4x. Okay, so here's the slope of this line. I need the slope of line that's perpendicular to this one. So I could rewrite this as over 1. So I have to flip it and make it negative. Alright, so my new slope is positive 1/4. Alright, now I have y equals mx plus b, slope-intercept form. Alright, now to figure out the correct b value, I use my point here. So let's plug in the x and y values along with the slope. So I have negative 3 is equal to 1/4 x, which is 4 plus b. Alright, 4's cancel out. I have negative 3 is equal to 1 plus b. Subtract 1, and b is equal to negative 4. So y is equal to 1/4 x minus 4. Done. Okay. For 111, all right, I have all this information given to me. I have to do a proof. Here's a statement and the reason. Alright, so I have AD is perpendicular to DC. CB is perpendicular to AB. AD is parallel to BC. Alright, these are all given. Okay, and let's see what I have here. AD is perpendicular to DC. Okay, that's a right angle. CD is perpendicular to AB. Oh, CB is perpendicular to AB. Okay, CB. Alright, got that. AD is parallel to BC. I'm trying to prove that the triangles are congruent. Alright. So, I know that these angles here are congruent. Those are alternate interior angles. So I'm going to say angle 4 is congruent to angle 3. Those are alternate interior angles. Okay. And I know that these angles are congruent. You just say right angles are congruent. That's all there is to that. Okay. And now I know they both share this side in common. So AC is congruent to AC by the reflexive property. Alright, and now part 7. I have triangle ABC is congruent to triangle CDA. By which shortcut? AAS. AAS. Done. Okay, I have to set up a 2-column proof here. Okay, so they give me FE is perpendicular to EH. They give me HG is perpendicular to EH. And J is the midpoint. Of EH. Okay, so 1, 2, 3, these are all given. Let me label the diagram with this given information. Okay. So I have FE is perpendicular to EH. That's a right angle there. And I have HG is perpendicular to EH. Okay, J is the midpoint of EH. Okay, so I could say EJ is congruent to JH. That's by definition of midpoint. Okay. And then I know that E is congruent to H. That's just right angles are congruent. They have the same measure. Alright, then I know that these are vertical angles here. Okay, so I have angle EJF is congruent to angle HJY. G. And the reason, those are just vertical angles. Okay. And for part 7, I can prove the triangles are congruent now. By what reason? Angle, side, angle. Angle, side, angle. Done. All right, 113. Statement and reason. All right, 1, I have AB is parallel to DC. I have AD is parallel to BC. All right, AB is parallel to DC. All right, so that's given. And AD is parallel to BC. That's given. Okay. And let's see what I could do now. I know that these angles are congruent. These are alternate interior angles. And then I have these angles are congruent. Those are also alternate interior angles. Alright, just to be clear, I have these parallel lines here. And this is the transversal. That's what makes angle 1 and angle 2 alternate interior angles that are congruent. Then I have these two parallel lines here. And I have this transversal once again. And that's what makes these angles congruent. They're alternate interior. Okay, then I have this side that they share in common. So that's AC. AC is congruent to AC. And that's by the reflexive property. And then to finish off now, I have triangle ABC is congruent to triangle CDA by what shortcut? ASA. ASA. Done. The last problem of the review. 2-column proof. Alright, the first piece of information, angle 1 is congruent to angle 2, and angle AJB is congruent to angle BKA. Alright, reason, given. Okay, let's label the diagram. 1 is congruent to 2, and AJB is congruent to BKA. Okay, this is actually a very easy problem to do. They pretty much give you all the information you need. Alright, so what you want to notice is that we're working with this triangle here, the blue triangle, and the green triangle. Okay, so they already share two angles in common, then they share this side in common. So AB is congruent to AB, that's by the reflexive property. And then 4, I can prove the triangles are congruent now. By what reason? That would be A, S. A, S. Done. Alright, if you need any help with any of the problems, if there's anything you're not understanding, please make sure to ask for help. Alright, that's it. Alright, you cannot use your yellow sheets on the final. You cannot use a calculator. You have to know your stuff. Alright, it's all up to you. Make sure to ask for help once again if you need it. That's it for the review.